Okay, let's try this worksheet here. All right, this is again, for those of you in SPM, this is in chapter 2. Okay, for those of you in chapter 2 of your form 5, for those of you in IGCSE, this is actually chapter number 4. Okay, um, the question states it's about charge, current, voltage, and energy. It's basically if you look at your work, if you look at your notes that I've given you, it's actually this page here. Okay, so a lot of you have been asking me or rather complaining. There's a lot of equations in this chapter, but the reason there's so many equations is because all the equations are basically a derivation or combination of just four main equations. Which are they? Remember in class I told you it's this one here and this one. Okay, so basically if you don't want to memorize the rest of the other equations here, you just need to be familiar or be good with using these four equations here. Okay, they are the voltage one, the current, and also Ohm's law. These are the three main ones, and also that's work. Right, work done. Okay, the rest of them, this here, I've shown in class. You can actually you can actually combine the four of them together to come out with the rest of this here. So let's take a look at a few questions. Let's take a look at question number 2. Okay, so question number 2 says that there are 2.25 10 to the power of 20 electrons. That's a lot of electrons flowing in a light bulb in 2 minutes. Calculate the current that flows through the bulb. When you see this kind of question, you must know which equation to use. Okay, so this question says that there's this many electrons and each electron carries this amount of charge. So the closest equation that I can get, if you look at your notes, okay, it's if you look at any of them, so this one here, there's current and there's charge, so it has got to be equation number 2 here. Okay, so let's come back here, let's write out the equation. I equals to Q over T. Okay, remember Q is the charge, right, which is in coulombs, and T is time, which is in seconds, and current is amperes. All right, so current is just the rate of change of charge. Okay, so I need to get the total charge. In this case, since there are 2.25 10 to the power of 20, even saying that out is painful, times 1.6 times 10 to the power of minus 19 coulombs. So some of you asking me why I multiply it is because each electron carries this amount of coulombs. So I need to multiply, since I have this many electrons, I need to multiply with this to get the total amount of charge. Okay, I'll use this example. If 10 boys carry 5 apples, what's the total amount of apples? Is 10 times 5, which is 50 apples. So okay, let's calculate it out. 2.25 E20 times 1.6 E, I say E because that's my calculator short from E19. So not very big because the charge is very small, so I'll only get 36 coulombs. All right. Okay. So all I need to do is how long? 2 minutes, so that's 120 seconds. Remember, always convert to SI, especially when doing this type of questions. I equals to 36 coulombs divided by 120 seconds. All right, 36 divided by 120. So that's around 0.3 amperes. Okay, so pretty easy. If you're familiar with which equation to use and how to convert units, quite easy question. Let's try another question. Question number 5. So it says that when lightning strikes, 500 coulombs of charge is transferred and 1.6 times 10 to the power of 9 joules of energy is dissipated. What is the potential difference? Remember, when you see the word potential difference, that's voltage, okay, or V. So between the cloud and the earth. So coming back to your formula sheet, okay, a reminder, okay, by the end of the class and the semester, you should have all of this formula sheets in your in the formula sheet I asked you guys to prepare. Okay, so which equation? The question wants you to find the volt. They give you the charge, and do they give you the energy, or they give you any time? They give you, yeah, the energy. So that's joules. All right, so which is this? So J W Q matching, right? Of course, you should understand, shouldn't just look at symbols and try to match the symbols. This is physics, not preschool, right? Okay, so V equals WQ. Okay, joules is W, same thing. Work, energy, heat. Okay, I've always told you guys it's the same thing. So let's write out the equation here. That's marks for writing. So potential difference is just the work to move charge. Okay, the question wants to find the V, easy. 1.6 times 10 to the power of 9 divided by 500 coulombs. And you get, that's a huge amount of energy. 3.2 million joules. That's a lot of energy. Is that 3.2 million? 3.2 million joules. Okay, that's how you do this voltage question. Okay, let's try yet another question. Okay, this is question number 9. Okay, the question says that a conductor carries with a resistance of 50 ohm and a potential difference of V. The question wants you to find the current. So you should begin to see a pattern now. What we're going to do is write out all the symbols, go to our formula sheet. Okay, take a look at this is the lazy way of doing things. All right, take a look at which equation. Okay, just to save time, is this one here because it has V, I, and R. Okay, you can try the rest. You can come up, but it's going to be a bit tricky if you use the other equations because they don't have an R here, right? V or I R. So I'm just going to write V over I. This is Ohm's law, the famous Ohm's law. Okay, those of you taking electrical engineering, yeah, you'll be, or even engineering in general, you'll be seeing this a lot. Okay, VI 12, so it's just 12 over the current, which is what we're trying to find, and resistance is 50 ohm, as all in SI units, no problem. Just rearrange 12 over 50, and you get an I. 12 divided by 50, and you get I equals to 0.24 amps. Hey, I'm a messy guy. I have empty space and I prefer right outside the box. Okay, alright, so that's how you do this question. Let's try one last question. Okay, I think the last question is a bit more tricky to do. Okay, involves a bit more thinking. So the question states that we have a 48 ohm resistor connected to a 24 volt power supply. Calculate the amount of energy or work dissipated after resistance 2 seconds. Alright, so as per routine, let's take a look. What symbols do we have again? So we have RVWT. Coming back to here, do we have RVWT? We have everything, but it's very tricky because let me write it here, RVW and T, and the question wants us to find the W. All right, so the question wants us to find W. If you look at the equation here, not one of them actually has all the equations. Okay, so if you take a look at the bottom here, you can actually see that some of the equations here might have all the equations, but I'm going to show you, as I said, you only need 4 of this in exam. All right, you only need 4 of this and a lot of practice on. You can actually combine them to get your final answer. Okay, I'm going to show you how I do it here using the combination method. So first of all, I'm going to use this equation here where work equals to V I over T, voltage times I over T. Okay, and what I'm going to do is I'm just going to write here W equals to VIT. Okay, this is the 4th equation here. Okay, the question says that W, right? I have W, I have V, I have I. If you look at this equation here, I don't have I have V, I have T, but I do not have the current. Okay, so how do I actually solve this issue? Do I have charge? Okay, I don't have any charge, so I can't convert charge to current. But okay, I'm just going to do this very quickly. So what I'm going to do is I'm just going to take this equation here. Okay, since I have V and I, what I'm going to do is I'm going to replace I, okay, equals, since I have R, what I'm going to do is I'm going to replace I equals to or rather, sorry, my mistake. What I'm going to do is I'm going to write down Ohm's law. V over I equals to R. Okay, and I'm going to get rid of this I since my questions here, these questions here do not have an I. So I'm going to get rid of the I. How I do this is I'm going to write out Ohm's law. I'm doing this quite fast because I have a lot of practice with this, so I'm familiar. You guys might take a while to actually think of how to do this. So what I'm going to do is V over R equals to I. And I just rearrange this, and when I write in this equation, it's just going to be V, and I has been replaced, so this is going to be V over R, and this is going to be T. Alright, what I did was I simply just took this I, used Ohm's law, applied Ohm's law, rearranged the equation, and replaced the I with V over R, and I get a new equation. I get V squared over R times T. Okay, and now what I'm going to do is I'm just going to write out the power, and what you're going to do is 240 volts squared over R, 48 times T. Time is 120 seconds because it's in SI unit. All I need to do is plug into my calculator, and I will get 144,000 joules. Alright,